Okay, so we're going to concentrate on the next couple of days on ratio because it comes up quite a lot in the exams, and it's going to be a popular topic. Okay, so we've got a question here. The workers in the company are in the ratio female to male. So as always, please give the numbers some headings in ratios, help you to see what's going on. It says what fraction of the workers are female. So we need a fraction. So under what do we know? A fraction looks like that with a divisor line. So what fraction of the workers are female? So there's one female for every 5.5 in total. So we can't have a fraction with a decimal in it, so we have to times by 2/2 to get 2/11. Okay, so the answer to this will be 2/11. Now the 5.5 came from the fact that you add up the component parts, so there's one female for every 4.5 males. So if you think of this in groups of 5.5, and that's how we get the fraction for females, 1 out of 5.5. Then we double up to get a proper fraction, because a proper fraction must have integer parts. Okay, so that's really important. It then goes on and says the company has 150 female workers. How many workers are there altogether? Okay, so basically we worked out here that the 2/11ths were females, so 2/11ths of the workers is equivalent to 150. So 1/11th will be half of this. So half 150, we get 75. And because 1/11th is 75, then we do 75 times 11 to get 825. So the number of workers altogether is 825. So basically, just to go back through and just check we've done what the question wanted. So what fraction? Yeah, we're in a fraction, so that's fine. The company has 150, how many workers are there altogether? Yeah, I've done that. And we recognise this question was about the relationship between the fraction of females and the total number of female workers. And then we worked it through to get the total number of workers altogether. Okay, so that's one example. Okay, so then we get another question here where it's telling us the ratio of A to B is 2:7. It's telling us what the value of A squared is, and it says work out the two possible. So there's the clue, two possible values of B. Okay, so the usual thing, give the ratio some headings, 2:7. Now, because they've told us A squared is worth 36, then we know to get A, we square root 36. Now, what we need to remember about square rooting is there are two possible answers, hence the reason they're talking about here, that two possible values of B. So when we do the square root of 36, we need to remember when we square root, there's a positive answer and there's a negative answer. Negative 6 squared will be 36, and positive 6 squared will also be 36. So two possible answers there. So to get the one of the values of B, then we know the A value, it could be positive 6, and to get from 2 to positive 6 we had to treble, and like all ratios, whatever you do to one quantity, you do the same to the other quantity. So times by 3 there, so 21. So B could equal 21, or B could equal, well, the other possible answer for A was negative 6. And to get A to become negative 6, from 2 to negative 6, we times by negative 3. So we times by negative 3 here, and that's 7 times negative 3, so it is negative 21. So B could be positive 21, or it could be negative 21. Okay, so that's another example of ratio. This question talks about the density of two different liquids. So again, A to B, write the headings, write down the numbers they give us. So they're telling us we're working with 19 to 22. They're telling us the mass of 1 cubic centimetre of liquid B is 1.1 grams. So that's important. 5 centimetres cubed is mixed with 15 centimetres cubed of B. 20 centimetres altogether to work out the density. Okay, so there's a trigger word, and because they talk about density, what do we know? Well, we need to remember the formula for density is density equals mass over volume. Because it's a 3-letter formula, then it can be written in the classic triangle to help us decide how we can work out any one of the three values if we know two of the other ones. So it's asking us to work out the density. So we know the volume for the liquid. So for liquid C, we know the volume is equal to 20 cubic centimetres. The question wants the density, and we need the mass of the liquid. Well, we don't know that, but we do know how much of A and B are used, so we need to work out the mass of A and the mass of B to make the total mass of C. They told us that the density of, so if we think about the density first, so they told us the density of B was 1.1. The reason we know that is because density equals mass divided by volume. They're telling us it's 1.1 grams and we have 1 cubic centimetre. So when we do that division, we get 1.1 grams per cubic centimetre. So for B, we know the density is 1.1. Well, to get 22 to become 1.1, we had to divide by 20. So we're going to do the same here because they're telling us that the densities are in this ratio. So we're going to do the same here, divide by 20. So that'll give us an answer of 0.95 grams per cubic centimetre. Grams per cubic centimetre. We don't normally write the units on the ratio itself, but because ratios have to have the same units, then because this was grams per cubic centimetre, this will be grams per cubic centimetre. Okay, so we can work out the mass of A in liquid C. We can see here that the mass, if we cover that up, it's going to be density times volume. So mass is density times the volume. We've worked out the density is 0.95, and they told us in the question that it was 5 cubic centimetres. So when we do that, so 5 9 is 45, 495, so 495, 0. Nope, it's 4.95. Okay, so 95% of 5, 4.95. Just work that out. 95 5s, 5 5s 25, 5 2 over 9 5s so 45, and 2 makes 47. Yeah, I knew it didn't look right. So that's 4.75 grams. And then we have the mass of B to work out. So we've got the mass of B in liquid C. Again, we've got mass is equal to density times volume. In this case, they told us the density was 1.1. They've told us the volume was 15. And when we do that calculation, one of those is 15. A tenth of that is 1.5, so it's 16.5 grams. Okay, so the total mass of liquid C is going to be 4.75 grams plus the 16.5 grams. So we've got 16 plus 4 is 20, a half from there and half there makes another 1, so that's 21, and we're left with 2.25, so 21.25 grams. So the question actually wanted the density of liquid C, so we need to go through and actually now work out the density. So the density is the mass divided by the volume. So we know the mass is 21.25 grams, we know the volume is 20. So we do that, divide by 10 and then double it. So divide by 10 is 2.125, double that gives you 4.25. So it's 4.25 grams per cubic centimetre. Units, that was in grams, that was in cubic centimetres, so the unit for the density would be 4.25 grams per cubic centimetre. Okay, so under U what, the T is test your answer. Does the answer make sense? Well, we worked out that the density of this was 0.95, the density of this was 1.1. So here 4.25 does not make sense. You know, when we do the test, we can see that these two had a density of around 1. So when you mix those together, you can't really get a density bigger than 1, so 1.1 or so forth. So here we must have made a mistake. And when I check this, then we can see that 21.25 divided by 10 is definitely 2.125, but then I have to divide by 2 to divide by 20, not double it. So we divide this by 2, so we end up with 1 point. 2's into 2 is 1, 2's into 1 doesn't go, 2's into 12 is 6, and 2's into 5 is 2, 1 over 10, so 1.065 grams per cubic centimetre. Okay, so that makes much more sense. So again, it's important, check your answers, just in case you make a silly mistake in the rush of doing the question. So 4 did not make sense, so we checked it, we went through, and we found out the answer to be 1.0625 grams per cubic centimetre. Okay, so that's an example of ratio mixed in with densities. One last question then for this day's exercise. So we've got in a breakfast cereal, 40% of the weight of fruit, the rest of the cereal is oats. So under the what do we know? We know 60% of the weight is oats then. Write down the ratio of the weight of fruit to the weight of oats. Give your answer in the form of 1 to n. Okay, so fruit to oats, they told us it was 40% fruit to 60% oats, and they want the answer in the form of 1 to n. So in other words, we want to go to 1 to some number here. Well, to get 40 to become 1, we have to divide by 40, and to get 60 down to that, we also have to divide by 40. Do the same to both parts of the ratio, or both quantities of the ratio. So 60 divided by 40 is 1.5. So the answer here will be 1 to 1.5. It talks about a different breakfast cereal now, so be careful. It's about a different breakfast cereal made of fruit and bran this time. The ratio of weight of fruit to the weight of bran is 1 to 3. Okay, so let's get that written down. So it's fruit to bran, 1 to 3. And it says what fraction of this cereal is bran. Okay, so we can see that altogether there's 4 parts to this. So 1 plus 3 is 4, and 3 of those parts is bran. So the fraction will be 3/4 and 1/4. The question wants the bran, so this will be 3/4. Okay, so that's just another example of ratio. That's it for today, guys.